Okay, fifth graders, here's lesson 1-5, and it's pages 22, 23, and 24. And we're talking about comparing decimals. And before we go any further, I wanted to touch on the greater than or less than or equal to signs. And I think I can safely assume that everybody knows what the equal sign is. But this is the sign for less than, and this is the symbol or sign for greater than. And I actually had deleted a previous video that I had messed up on and got them confused. I guess it's my old age. But anyways, so I'm going to replace it with this one. And just wanted to touch on these really quick. And an easy way to remember is that if you look at the arrow, sort of like the way it's pointing, the direction it's pointing, that one's pointing to the left, and this one's pointing to the right. It's pointing in that direction. The symbol is always pointing to the smaller number, so that way you wouldn't get confused. So if I put a 10 here and a 3 here, well, what symbol should I put in there? I should put in this one. That would be 10 is greater than, notice the same direction it's pointing as this green one right here, greater than 3. And that makes sense. 10 is greater than 3. So what if I was to reverse those? What if I was to put two numbers? Let's put 3 here and 10 here. What symbol would I put in there? Well, I would put 3 is less than 10. Notice it's pointing the same direction as that one. That's a less than symbol. 3 is less than, smaller than, okay? Doesn't have as great a value as 10, okay? So just remember that it's always pointing to the smaller number. And they give you an example right here. 8 is less than 10. 9 is greater than 6. Okay, so there's some greater than and less than symbols in your lesson in 1-5 that you have to deal with. I just wanted to make sure you guys knew that. Also, when we played quiz the other day, I think we used those symbols too. That'll help you remember. Anyway, step 1, it says line up the decimal points and then start at the left and then compare the digits of the same place value. So, so they've got a 3.576 and a 3.432. So the 3's are the same, so we're not going to worry about those. But then we see a difference here. Now, this is assuming we've got them lined up. The very next digit after the decimal, for this one it's a 5, for this one it's a 4. Which one's larger? The 5 is larger. This is going to be the larger number. And as they put here, you'd compare them. 5 is greater than 4. Again, notice that they're using this symbol here, pointing in that direction. Okay. So, critique reasoning. Valerie said that 12.68 is greater than 12.8 because 6/8 is greater than 8. Is she correct? Well, no. Place value matters. Okay. So let me they give us another example here. Let me move this up some, and I'll just go ahead and erase these. It was another explanation I was working on. Okay, so I think I went a little too far there. There we go. Okay, let's see here. Oh, they were talking about cockroaches up here at the very beginning. I didn't even touch on that, and I almost forgot. So let me show you guys something here. It's kind of interesting. Let's see here. I want to display layer 2, and there's a nice looking picture of a cockroach. Man, it looks so sleek and smooth. All kinds of cockroaches, even in this example here. There's American, there's Australian, and Oriental cockroaches, and there's other types too. But here's some other interesting facts about cockroaches here. Check this out. Cockroaches have been around since the time of the dinosaurs, quite a while. A cockroach can live almost a month without food. A cockroach can live about 2 weeks without water. That's significant. I think we can go about 3 days without water. And some female cockroaches mate only once and stay pregnant for life. Holy cow. A cockroach can live up to 1 week without its head. Can you imagine that? A week without its head. In fact, when they finally die, the reason is from lack of water, because they can't drink any water. That's why they really end up dying. They breathe. If you look at a cockroach, and I'm putting little dots here on the cockroach up above, but they're not sticking because it's a different layer. But they have little portals all over their body, even in their legs, and that's where they get their oxygen from. And their nervous system throughout their body is not centered in their head, so that's why they can keep living even after you cut off their head for quite a while. Cockroaches can hold their breath for 40 minutes, and cockroaches can run up to 3 miles an hour. That's pretty fast. So let's see here. Okay, yeah, I think I'm done with that. So let me just move this up. Okay, so here's the other example. So it says, order the cockroaches from least to greatest length. And when you guys read these questions, make sure you read which they're asking you to do here. So in this one, it's least to greatest. In other ones, it's greatest to least. So pay attention to that. So here's what they did. They lined up these cockroaches here, here, and here. And they just compared them. And so the 3s are the same, so that's irrelevant. But the second set, there's 2 5s. So then we have to compare these two and see what they look like. And so that's what they've done here. So the 5s are the same, or the 3s are the same, 5s are the same, and then now we've got an 8 that's larger than the 7. So this is the largest one. That's the greatest value. And so that's going to be the first one listed here. Oh, wait. It says from least to greatest. What's the first one that got kicked out? It's this one. So that's going to be the first one listed. What's the second one that was kicked out? It was this one here. That's going to be the second one listed, and this is the greatest one, and that's going to be the last one because it's from least to greatest. Okay, guided practice. Do you understand? Scientists measured Madeira. I'm not sure. Don't think I'm pronouncing that right. Cockroach, and found it to be 3.44 centimeters long. Toby says that the Madeira is shorter than the Oriental because 3.44 has fewer digits than 3.432. Is he correct? And the answer is no, because the number of digits really doesn't matter. What's important is that you compare them, you line them up and see which one, when there's a difference, which digit is larger first. Okay? And so, I mean, we could take these and line, here's a 3.44. Make sure you line them up properly. And here's a 3.432. Well, let's look at the first pair. They're the same. They're the same. Oh, now here we have a difference. There's a 4 and there's a 3. So which one's larger? This one's larger. Even though this one has more digits, it is the smaller of the two. All right. So you can explain that any way you want. Okay, here we go. We're talking about those less than and greater than and equal to symbols. Remember that, and I'll back up here just for a moment. I'll have to get rid of that layer so you guys can see that again here. Remove layer 3. Okay. So less than and greater than. Remember, it's always pointing to the smaller number. That should help you guys remember. It's always pointing to the smaller number. So we can write these down here. I'm writing down the first one in number 2. It's 3.692. And then 3.697. All right. This is number 2 that I'm looking at. These two right here. Okay, the 3's are the same. That doesn't matter. 6's are the same. 9's are the same. Oh, here's the difference. In the hundredths place, the 7 is larger. So we're going to point to the smaller number. Okay, right there. 3.692 is less than 3.697. So let me explain it one other way here. I'm just going to use x's in place of numbers here, okay, and a decimal, and then 3 more x's. And so here's another number that we're comparing, okay. Just start looking at the digits and look for a difference. Are these the same? Are these the same? Are these the same? And as soon as you see a difference between two digits, look for the larger one, and then you will have the larger number. And it doesn't matter whether it's into the decimals or not. These could be the same. These could be the same. Maybe these two are different. The first pair of numbers that you see a difference, that's going to be the larger number. Let me give you an actual example. So let me write down a number here. 3,426.178. And I'm going to compare that to 3,426.159. Okay? So look at this. 3's are the same, 4's are the same, 2's are the same, 6's are the same, 1's are the same. Oh, here's the difference. 7 and 5. Which one's larger? Well, the 7 is larger than a 5. This is the larger number. So that's all you have to do when you're comparing decimals. Just line them up, and when you see a difference, whichever one is larger is the greater decimal. So for these next ones here, same thing. Just line them up. You guys can do that. Line these up. All right. Yeah, same thing. Line all these up right here. You guys can do that. All right, let me move this up. Last page here. I want to keep this under 20 minutes here. Problem solving. Explain why it is not reasonable to say that 4.23 is less than 4.135 because 4.23 has fewer digits after the decimal point than 4.135. Okay, so I'll explain this. The number of digits does not matter. I would say the matching place value or values does. So as you line them up, if they match, you just go to the next one on the right. If they match again, go to the next one on the right until they don't match, and then you see which one is larger. Number 12, Carlos wrote 3 numbers between 0.33 and 0.34. What numbers could Carlos have written? Okay, so if I drew a line here, I'm going to draw a line. Okay. And I put, whoops, I put right here is 0.33. And then right here is 0.34. So right here might be 0.331. And right here might be 0.332. And right here, 0.333. And then about in the middle here, what would we get? We'd get 0.335. And then right about here, 0.336. I think you guys can see where I'm going with this. 0.337. And then right about here, we're going to get to 0.339. When we add 1 to the 9, 0.339, if I add 1 to that, which is going to be the 0.34, the 9 becomes what? Becomes 10. So I could put down a 0 and I add 1 here, so it becomes 0.34. Okay. So it says Carlos wrote 3 numbers between 0.33 and 0.34. What numbers could Carlos have written? Well, take your pick. Any of those, and a couple more that I didn't write down, could have worked. Okay. All right. Number 13 here. Draw lines to match each decimal to its value on the left. I'll just do one of those for you. How about the first two right here? 0.75 is the same as 0.750. Because remember, adding zeros on to the end of a number, that doesn't change its value. Okay, so those two are the same. All right, number 14. Is 0.5 greater or less than 6 over 10? Draw a number line to show your answer. So here's my number line. Okay, I'm going to put 0.5 right here in the middle. 0.5. Okay. What's another way of saying 6 over 10? You guys should remember that from the previous lesson. That's going to be 0.6. Well, where's 0.6 on this number line? 0.6 would be right about here. 0.6. This would be 0.7. 0.8, 0.9, and right about here would be 1. Well, I guess right here would be 0. And right about here would be 0.1, 0.2, 0.3, 0.4. Okay? Let me move this up a little bit. We're almost done. Trying to keep these under 20 minutes, or right around 20 minutes or less. I think you can compare those scores. Let's see here. 1, 2, 3, or 4. One digit in her floor score is not visible. List all the possible digits for the missing number. This is the missing number here that they're talking about. They were posted on the scoreboard in order from highest to lowest. So this is the highest, this is the lowest. So we're working our way down. So that could have been a 1, a 2, a 3, or a 4. All right. And check which statements are correctly compare two numbers. Well, 0.1 is less than 0.125. That's true. Okay. 0.2 is less than 0.1. No, it's not. That's not true. 0.125 is let's see here. 0.125 is greater than 0.13. No. And what have we got here? 0.125 is greater than 0.12. That's true. Okay. All right. I'll let you figure out 18 on your own. That's it. And I'll post this up for you guys since I pulled the other one down.